Okay, the agenda I want to cover off on today, I'll move into the presentation proper, is I want to talk about a little bit about Group A herbicides and how they work, some of the implications for resistance management, how to make those work effectively. The Group A herbicides we're going to talk to today have been increasing in frequency of application, particularly in the northern grains region over the last few years as we're battling herbicide resistance in general, but specifically glyphosate resistance. So why we put this presentation together today was to talk a bit about the Group A herbicides and understand what we need to do to make this work most effectively and try to minimise the potential chance of developing resistance to that mode of action. So hence that's why we put it on at this time of year in particular, as we're moving into a high use pattern for these herbicides when we're using them in crop to target grass weeds or potentially in fallow as well, and I'll talk about those as we go through the day. At this point in time, I'll make mention of a second webinar that we're going to be running at the same time next week, and that will be specifically targeted at barnyard grass management, which will also somewhat overlap with some of the Group A strategies that I'll talk about today, but the second webinar is really specific to managing barnyard grass, understanding the ecology and what we're going to do as far as developing systems to manage it. So if you're interested in this area of grassweed control, particularly in the northern grains region, then really find it worthwhile to call in for the webinar next week as well. But as you can see there from the agenda, I want to talk about the Group A herbicides in general, how they work, and then we'll move into where we can use them from a registration point of view, and I'll talk specifically around some strategies that we can use in crop or in fallow to get the best performance out of these herbicides. The plan for this webinar is to present for approximately 30 minutes, and then we'll open it up to the questions that come in during the webinar, and we'll try to address those the best we can. Should be all done within 3/4 of an hour or so, depending on how many questions we have at the end of the day. Sometimes it takes a little bit of time for these slides to move on, hence why the pregnant pause. Okay, this is the one slide that is the heavy science for the presentation, and what I firstly wanted to do was to talk about the mode of action of Group A herbicides. While it's a little bit heavy, it's important to understand this because it really dictates how we use these herbicides best in the out there in the environment. So what the Group A herbicides do, they inhibit an enzyme. So what is an enzyme? An enzyme is a chemical that's available in the plant, manufactured within the plant, and its role is to facilitate some sort of chemical reaction that's going on in the plant. So the enzyme we're talking about with Group A herbicides is they inhibit or they block or they knock out an enzyme called acetyl coenzyme A carboxylase. Now it's not important to know what that enzyme is, but in the literature you'll see it quite often abbreviated to ACCase. So our Group A herbicides block this ACCase enzyme. We call them Group A herbicides in Australia. If you're talking to a North American, they'll call them Group 1 herbicides, but they work the same way. They block this enzyme. So what does this enzyme actually do? It facilitates a chemical reaction in the plant that creates certain fatty acids which are used basically in construction of new cell membranes and waxy cuticle, particularly in grass weeds. So these are required in the growing weed. So as the weed's growing, it's creating new cells, it's needing to have this building blocks of cell membrane and waxy cuticles to create this new growth. So if we knock out that enzyme, the reaction can't happen, those fatty acids can't be produced, and therefore growth is stopped, and then therefore the plant dies. So this is fairly specific. This target site that we can target with these herbicides are relatively specific to our grass weeds only. So in most situations, these herbicides are selective to our broadleaf plants. So we can use them in our broadleaf crops with a couple of minor exceptions. The other thing that's important to understand is this ACCase enzyme is predominantly located in the chloroplast of the leaf, and in particular in what we call the meristematic tissue. And that meristematic tissue, that's where all the new cell division happens and the new cell growth happens. Where's that found? It's found at the base of the young leaves and at the crown of the plant, again in these young growing plants. So again, it's really important to understand that that's where this production of this enzyme occurs within the plant. So when we pull all that together, what it tells us is we need to target very young, actively growing and grass weeds, up to the early tillering stage in particular. That's when the production of this ACC enzyme is at its maximum within the plant. And as the plant gets older and particularly moves from a vegetative stage to a reproductive stage, its production of this enzyme drops off significantly. So if we're going to go and spray large weeds that are approaching a reproductive stage with this group A chemistry, there's no substantial level of enzyme that's working within the plant. So there's no real place for this herbicide to work. And so hence that's why these herbicides work much better on very small, young, growing plants and generally fail to deliver when you're talking about more mature plants. So what group A herbicides have we got available to us? This group of chemistry, or this mode of action, was discovered back in the 1970s, and since then there's been a lot of different herbicides launched both in Australia and around the world. And I've just listed here a number of Group A herbicides that are registered for various situations in grain cropping in Australia. So you can see there it's basically broken up into 3 subclasses. So the first column on the left-hand side, the aryloxypenoxypropioniates, big long name, we refer to them in the industry jargon as the FOPs. So all these herbicides finish with their active name in FOP. And they're all a subgroup of this chemistry. There's also the DIMs, the middle list down there. Again, they have the same mode of action, they target the same enzyme, they just bind at a slightly different place within the crop, within the weed, sorry. And then we have a third subgroup called the DIMs, of which there's only one representative there, which is penoxidine or axial. So we have 3 different subgroups within Group A chemistry, and I'll talk a little bit about some of the differences and some of the similarities between those groups as we move further into the presentation. The ones that are highlighted in bold there are the herbicides that are available for us to use in other grass crops, so particularly cereal crops. So we have 2 of those herbicides, diclofop and traloxydim, Hogras and Achieve. Probably some of the first examples out there and some of the oldest Group A herbicides. They are naturally selective to grass crops, the cereal crops. They don't really affect the cereal crops, so hence we can use them within the crop. The other 3 that are highlighted in bold there, clodinafop, phenoxaprop and penoxidine, those herbicides can be used in grass crops, but only because within the drum we put a crop safener in those formulations which allow them to be able to be used over the cereal crops. Most of the rest of the herbicides there in black don't have a safener in the formulation, so hence they will damage cereal crops and really can only be used in broadleaf crops because they don't have the safener in the formulation. There's also 2 herbicides I've just added in there which are in grey, cyhalofop and profoxidin. Those 2 herbicides have natural tolerance to rice, and so hence they're basically specific herbicides used to take grass weeds out of rice, and they're a little bit different from that situation because they have that selectivity to rice. So we've got 3 different subclasses that we're dealing with within that mode of action. Okay, next slide I wanted to talk about was the symptoms that you observe out in the field when Group A herbicides are applied. So what happens when we apply the herbicides is that we get fairly rapid movement when the spray is deposited on the leaf, and it moves into the leaf relatively fast, within a few hours. And the choice of adjuvant is really important for these Group A herbicides because mostly they are not soluble in water. They're basically, we use them as generally formulated in an oil-based system to allow them to get into the plant, and we use, generally speaking, an oil-based adjuvant to get that rapid penetration into the leaf. And that's really important. We want to get it in before any rainfall or any degradation on the leaf surface. So we can get them into the leaf relatively fast. Then they've got to move from where they've hit the leaf to where they've got to work within the plant. And as I mentioned on the first slide, the meristematic area where they need to work is either at the crown of the plant or it's at the base of the leaf. So these herbicides need to translocate to those growing points. So what's the important things to think about in that situation? Well, if our weeds are stressed because they're in frost shock, or they're too dry, or they're waterlogged, or any sort of stress that's going to be slowing down the metabolism of the plant, it's also going to slow down the translocation of the weed. So that will be important in that we may get less than adequate control in the situation where the plant may be stressed. That's the first thing to think about. Also think about the droplet spectrum and how that affects the weed size as well. So if we've got relatively large droplets rolling down the leaf blade and depositing in the crown of the plant or the leaf axil, then it's going to enter the plant very close to where it needs to work within the plant, and so hence you'll get relatively faster uptake of symptoms and weed control. If we're going to go and spray these herbicides with a fine droplet that's going to get captured on a very large mature plant up near the top of the canopy, it's going to take a very long time for that herbicide to move all the way down to the crown of the plant where it needs to go to work, and hence that'll be another reason why we'll get radically less control in those situations. Visually, what do you see in the paddock? So I've put a couple of photos in there to represent the sort of symptoms that we see as these herbicides are working. One of the characteristic observations from these Group A herbicides is the photo there on the left, particularly on these smaller weeds, that after a week or two the herbicide's got to the target site and it's started to work. It causes a breakdown at the node, and the centre part of the plant will be very easily removed, or falls out, or with a little tug that will easily come away from the centre of the plant, which is a classic symptom of these Group A herbicides at work. Visually, quite often we'll see the results as a purpling of the leaf, which then turns into brown necrosis material through ultimate weed death. But that may take up to 3 weeks in a lot of situations to actually occur. I talked a little bit about the choice of adjuvant, and I just wanted to put in this data set from some work undertaken by Northern Grower Alliance during this winter, and so this was targeted against wild oats and a range of different trials in this situation. So we've got 3 different trials, North Star and Mungandai data sets there, and the relatively challenging conditions of large weed numbers and effectively probably a level of Group A resistance that's happening there to these herbicides, and I'll talk about that a little bit later. And then the Bowenville graph on the right-hand side, lower weed numbers and probably a Group A susceptible weed population. But in this situation, 2 of the DIM herbicides were compared. So we've got Status or Clethodim, and we've got Factor butoxidim. Both of those herbicides had their recommended oil-based adjuvant added to them of uptake in the status of Clethodim, or supercharge in the status of, in the case of butoxidim. So that's the solid bars that we're comparing there. So you can see that the other point I want to make here as well is the actual application rate of the herbicide is relatively low, and that was designed specifically to be able to see differences between the various herbicide treatments. So we weren't in the situation where the herbicide rate was selected to give 100% control, and hence we'd see no differences. So it was designed to be a sublethal type application rate, so we can see the difference that the herbicide would make. Now what I wanted to show in this trial is the solid bars were the herbicide applied alone with the recommended oil-based surfactant there, and you can see that hopefully my pointer is going to work. We've got Status giving us various level of control over the 3 different sites. Butoxidim, the purple solid bars, giving us slightly better control in this situation, but again, suboptimal result. But what I wanted to highlight was in these trials we also had plus and minus liase or ammonium sulfate added to the trials. because that's something of interest to a number of the growers. Now you can see with the clethodim, in each situation going from the solid bars to the blue hatch bars, we have seen a increase and a substantial increase in some situations of control by adding liase to clethodim. However, you go to another dim herbicide, Britoxidim also had liase added to it, and you can see in all situations it's reduced the control. So I guess the point I wanted to make here is that the choice of adjuvant is really important with these herbicides, and make sure you're taking advice as per the label or other trial data that gives you additional advice. But yeah, really important to understand what adjuvants we need to use in what situations. So moving on to resistance, where are we at with resistance management? So typically there's a lot going on. So if we look at populations, and it's probably been ryegrass that's been understood and researched the most in terms of group A herbicides, what we find is that in a population that hasn't ever been exposed to group A herbicides, and we actually look at how many individuals out there have a different target site which allows them to survive an application of group A herbicides, the actual resistance frequency in an unselected population is typically quite high out there in field populations, even before they've had any exposure to this mode of action of herbicide. So the implication of that is if we go and then apply this herbicide and we don't do anything to control any survivors, we're going to very rapidly select for a population which has that different target site which allows it to be able to survive applications of this herbicide. So you can see the table there. This is some work from Chris Preston done a few years ago but still remains true, where we've estimated the number of years that are available before we would select a population that will have observable resistance in the field, providing nothing's being done with those survivors, and the survivors are just allowed to set seed and the seed goes back into the soil. So you can see there our group A herbicides that we're talking about today, somewhere between 6 and 8 years, and we would expect to be able to observe our resistance in the field if we haven't done anything to control those survivors, and that's our very high risk of herbicide selection, and is only beaten by the group B herbicides in the frequency that we would actually select in the field. And this is all based on the actual number of plants that are out there with this mutation, regardless of whether the herbicide is being used or not. The other thing that's important to understand from resistance management is we're not just talking about one change to a target site or an amino acid substitution that confers resistance in this situation. There's actually multiple different target site amino acid target site substitutions which have been identified in the research. So there's a number of different things that can happen which all make these herbicides not work in the field. So hence, I guess the key message here is it is a mode of action that's very prone to developing resistance very fast, certainly a lot faster than glyphosate or some of the other mode of actions that we've been using more extensively. So we really need to be driving at strategies which don't allow us to have survivors after a group A herbicide application, or very soon we'll burn this mode of action up. And there is some different target site binding, as I mentioned before, between the different subgroups, and that means that in some situations between different herbicides, depending on the amino acid substitution we're talking about, different herbicides may have different levels of resistance out there in the field. And so once one herbicide isn't working for us anymore, there may be an opportunity to switch to a different herbicide and still get an acceptable result. Hence, that's where resistance testing comes into play, so we really know what we're dealing with. Sorry, the slide just took a little bit of time to come up. I've put together a summary of the data from 2014 from the Charles Sturt University commercial testing situation that they've got up and running down there for a whole range of different herbicides, but I've just pulled the Group A data. And in the first table there in the middle of the screen, this is a summation of the samples that were tested in 2014, and they were tested against FOPs, DIMs and DEMs. for wild oats and ryegrass in particular, and the percentage of samples that were either determined to be resistant or developing resistance to this mode of action. So you can see here that the FOP herbicides for wild oats around 80%, or for both wild oats and ryegrass around about the 80% of all the samples that came in 2013-14 that were tested had a level of resistance to the FOP herbicides. As you move across to the DIMs, you can see the level is quite a lot lower for the DIMs that were tested, around that 10 to 14%, and the DENs somewhere in between in the 50 to 70% of the herbicides that come into the testing facility. Now, understanding that in a lot of situations, people are sending in samples for testing because they already suspect that they've got a resistant population, so hence we always expect the numbers to be at the high side of what we're dealing with. If anybody's interested in brome, there were only 5 populations tested and they were all susceptible at this point in time. The other thing that was interesting in this analysis was that they broke the ryegrass samples down into actual difference between various herbicides. So within the FOPs, there was decent numbers tested against diclofop and haloxyfop, and you can see there is a slight difference between the frequency of samples that were resistant to the various FOP herbicides. Diclofop being almost 90% of the samples, haloxyfop more like 70% of the samples, but still a very high number across the board. The more interesting one was the DIM chemistry. You can see here across the samples, and not every sample was tested for all herbicides, it was what was specified by the client, but you can see that to select and factor, a relatively low percentage come back as resistant. However, to achieve, still we're up around the 70% of the populations that were tested were resistant to achieve. Also, there was a state breakdown of the main states that sent in samples, and again, when you look at across it, New South Wales, 95% of the herbicides tested positive to FOPs, only 11% for the DIMs. Western Australia, not quite as bad, but still very high level, particularly to that FOP chemistry. Again, bearing in mind that these are targeted samples where resistance was probably expected in the first place. So what does that mean in the field when you try to compare that to some efficacy side of things? So again, presented this data from NGA, from some of the work they've done this season on wild oats, some of these same populations that were in one of those previous slides. So our FOP chemistry in this situation was represented by verdict, and we had 2 different application rates in there, 75 mils and 100 mils of verdict against 4 different populations. And you can see here we've got separation between the 2 different populations. So what I wanted to highlight here is we had 2 populations, one at Bowenville and one at Edgeroy. Now these populations you would suggest are selective to, are not resistant populations. We've got very high control with our FOP herbicides. We've kept the numbers relatively low. In the field, it was difficult to find weed numbers because those herbicides were working quite well over a number of years. In situations, the other 2 trials, North Star and Mungandai, the numbers were much higher, and you can see the performance of the FOP herbicides has dropped off substantially there. So they haven't worked anywhere near as well, and so therefore we would suggest that these are resistant populations, and that's also resulted in higher weed numbers. As you move across to clethodim, which was also in the same trial, you can see that generally speaking the numbers are higher, but again the Group A susceptible populations have worked much better than the Group A resistant populations from those 2 data sets down there. So you can see that even by switching application, again on these resistant populations we're getting better control, but we're not getting fantastic control. We still need to do something more. From an application point of view, how do we maximise the use of these herbicides? I mentioned we're talking about oil-based adjuvant system. The key point I've put in there is just make sure if you're going to use AI nozzles, air-inducted nozzles with oil-based adjuvants, you need to make sure we keep the pressure up. If we run these nozzles with an oil-based adjuvant at lower pressure, we can end up with droplet collapse. And that's particularly an issue when we're getting to the end of the runs with controllers. We slow down, the pressure drops. and we can get droplet collapse, and we can get substantial, suboptimal results in that situation. Generally speaking, we want a medium to a medium coarse spray quality. Around that 50 to 70 litres per hectare is the best way to get coverage of these herbicides, and I mentioned before why coverage is important. Oops. Tank mixers, just a quick slide on tank mixers. Check your labels for various tank mixers that are out there. It's generally pretty well covered on most of the labels, but I've just put in a couple of rules of thumb when we're using these herbicides out in the field. Generally speaking, if we're going to tank mix phenoxys with Group A herbicides, we will expect that the phenoxy will reduce the grass weed control. 2,4-D is, generally speaking, the worst. MCPA means probably next. MCPA LVE is the best. Some herbicide labels will say don't mix at all. Others may give some recommendations that you can use with MCPA LVE, but just understand that if we're going to mix those herbicides, we're probably going to expect some reduction in grass weed control. The other one that I wanted to touch on was, we're putting out our Group A herbicides, generally speaking, with an oil-based adjuvant. So just be careful if we're mixing some of the selective broadleaf herbicides over the top of some of our broadleaf crops. Suggestion products such as Blazer, Basagram, Brodel, those type of herbicides, which we may want to add for broadleaf weed control. The oil in the Group A mixture is potentially going to hot up some of those broadleaf herbicides, which may result in them damaging the crop. And so some labels recommend not to tank mix at all. Others recommend using a wetter rather than an oil. And the other thing that the oil can do in the formulation is antagonise the performance on some of the summer grasses if we're tank mixing with glyphosate. So in that situation, if we really want to add glyphosate to a tank mix in a fallow situation, make sure we keep our maximum use rates going to try to mask some of that antagonism, and maybe possibly consider a wetter rather than an oil. So I won't spend any time on this. I've just added this slide in for your reference down the track, just showing that we've got a range of Group A herbicides across a range of summer crops which we might be interested in spraying at this point in time. Most of them are registered in most situations, but not all are registered in all situations, so just follow your label directions in that situation. So if we're talking about controlling weeds within the broadleaf crop, what do we need to think about? So I talked earlier about the need to treat early small weeds where we've got this maximum production of the ACCase enzyme. We get this faster translocation, less risk of weed stress, and also by treating early we get the weeds out of the system, and that gives us the maximum possible yield by reducing that early crop competition. So all good reasons why we need to be treating our grass weeds as early as we possibly can. Also, when we're using them in an in-crop situation, the addition of crop competition for row closure increases the results we get. So you'll always see if you put out the same rate in-crop and then you go and spray a fallow paddock with exactly the same setup next door, you'll always get better control from the in-crop application because of this addition of crop competition. So really important to maximise that. And while we don't recommend treating large plants, what you will see is you'll get what we call these green skeletons. The weeds are stunted, but they're not completely dead. Quite often they'll still send up 1 or 2 panicles, and that's going to be really bad from a resistance selection point of view. So really try not to treat those large plants. I did mention in here stripping of sulfonylureas from a spray tank. Group A herbicides can pull minute traces of sulfonylurea herbicides out of the plastics within a spray tank, so that's something to be concerned about, particularly if you've used the herbicide tank somewhat earlier in the last 12 months for applying sulfonylurea herbicides, and then we're going to go and put these Group A herbicides over the top of broadleaf crops. They generally don't like any trace residues of sulfonylurea herbicides, so just watch that one. Make sure you've done a good decontamination. So just in summary there, from an in-crop weed control, use the competitive broadleaf summer crops and target these really to your grassy paddocks, because we can really get on top of our grass weed paddocks by this strategy. So what we're talking about is putting out a knockdown and a pre-emergent application, using crop competition to our advantage, and then really relying on the Group A herbicides to control any escapes from that earlier application. And if we do that, we should be able to achieve hopefully very close to 100% clean of grass weeds at harvest, and we can break the cycle from a lot of our problem grass weeds such as feathertop barnyard grass which have a very short persistence in the soil. So if we can get no seed going back into the soil for the summer, we're a long way down to breaking the cycle of those grass weeds. I want to quickly touch on fallow use. I mentioned before the lack of crop competition and also potential moisture stress. So we're putting a really strong selection pressure on our Group A herbicides in the fallow situation. So we really need to always double knock our grass herbicide, our Group A herbicides with a subsequent application of paraquat to make sure we get 100% control of those weeds and we're not letting survivors go and set seed and potentially introduce resistance into our field. So there's 2 permits in place, windmill grass with Targa in New South Wales, and the details are included there, and the other permit is for feathertop rhodes grass with haloxyphop or verdict prior to planting mung beans in Queensland. Key points: target early weeds, get onto them small, and make sure they're followed up with an application of paraquat very soon after application. Just highlighting that in a data set to highlight the importance of small weed control in fallow. So here we've got a series of 5 trials from central Queensland targeting feathertop rhodes grass with verdict at 150 mils in the first bar in each situation, and then plus a subsequent application of the double knock of paraquat. So against very small seedlings, you can see that verdict alone has given us a range of reasonable control, but certainly not 100% by any stretch of the imagination. By double knocking, we've got up above 90% in all situations. As we've moved into mid-tiller, a large variability across the trials by verdict alone. Even by double knocking with paraquat, we've still got situations where we've got less than ideal and less than optimal control. When we move into controlling mature plants, we're wasting our time with verdict alone, as I mentioned before, for all those various reasons. And even with a double knock, we still haven't got good enough control. So again, just highlighting the fact that we need to be targeting these very small weeds. There is also a permit in place for using the weed seeker to target spot weeds in the paddocks. Now, one of the challenges with the weed seeker is that they'll really only detect weeds around about the size of the top of a beer can. That's about the smallest that they can detect. So the weeds are going to be a little bit bigger when we're going to go and target them, even with an ideal setup for a weed seeker type application. So how can we overcome that? We really need to put out very high application rates to try to get us the best possible situation. So you can see there, I won't go through it in detail, but there's a range of different Group A herbicides and the application rates that they're registered for use by the weed seeker. And again, you can look at that at your leisure by looking at this slide or pulling up the actual permit. Last slide I wanted to talk about is the plant back situations, particularly to our grass crops, be it either cereals or sorghum. Now, a lot of the use patterns, particularly in fallow, haven't been very well developed, and they're still on permit, they're not on label, so hence a lot of these statements refer to other use patterns not really specifically designed for fallow situations. But if you look there, what this is showing is that a number of these Group A herbicides still do have a level of activity again in the soil, and hence we need to be a little bit careful about what's going on there and watch our plant backs to either cereals or sorghum. You can see with butroxidim, they're saying don't plant cereals for 4 weeks after application. There's actually no direction at all given on the clethodim label, so we just need to watch that one because we have no information to work on. Fusilade verdict, 12-week plant back. Targa, 18-week plant back is the current registered label in those situations for those products. Shogun is probably one of the least residual of the FOPs, but again, that label currently doesn't have any information to guide us because really there is no fallow claims yet on those labels. So just something to watch and be aware of, and try not to apply them too close before harvest. Probably gone over the half hour that I wanted to talk about, but they were just a few quick points that I wanted to highlight as we move through and start thinking about using some of those Group A herbicides, particularly over the summer in the Northern Grains region. Just like to thank the Grower Solutions groups in particular and other researchers who have given us the access to the information to be able to present this information to you today. So I acknowledge that. And last slide I'll pull up is a number of resources that also are related to this topic. Now, there's actually this top one up here. There is a new GRDC fact sheet which goes through a lot of what I've talked about today, which is available to download off the GRDC website. So you can read that at your leisure in more detail. And then there's a range of other different resources, either other fact sheets or videos, which are available, which all talks about various parts of this presentation that I've covered off on this morning.